So we're going to be looking at graphing some linear equations using the x and y intercepts. Okay, there's different ways you can graph equations. The x and y intercepts work well in particular situations, and it's really fast to do. You just have to be able to recognize what kind of equations work best for it. So let's talk real quick here first what we mean by the x-intercept and the y-intercept. So I have a graph there. It says identify the x-intercept in the following graph. So all really asking you for an x-intercept is where does it touch the x-axis, okay? So if we look at our graph there, right, it's intercepting the x-axis at that point, right? So for my answer, I want to put a coordinate. I'm not just going to put -2 because -2 isn't a location, it's just a number. So I want to write that as a coordinate, so that coordinate would be at -2, 0. So that would be my x-intercept, okay? Again, all that's asking is, where's it touching the x-axis? If I want the y-intercept, right, all that's asking is, where's it touching the y-axis? Well, it's touching the y-axis right there. Okay, so that's at 0, 1. All right. So the x-intercept, where does it touch the x-axis? Y-intercept, where does it touch the y-axis? Okay. And all linear equations, with the exception of 2, and I'll show you those here in a second, are going to go through those 2 axes. Okay, are going to touch there. So the 2 exceptions are, let me go up to them here. An example like this: graph the equation y equals 6. Open that up here. So what you'll notice is there's no x value in this. Just y value, okay? So basically it's saying, give me all the points on the graph that has a y value of 6. Well, if I look on my y-axis, 1, 2, 3, 4, 5, there's 6, right? So anything that goes through the y value of 6 on there is going to work for that equation. Doesn't matter what the x is. X could be anything. We just want a y value of 6. So you've got that horizontal line there through y equals 6. Sometimes that gets a little confusing because we think, well, y goes up and down, right? And that's the axis. But again, we're just looking for all of the y values in this case where it's equal to 6. So it doesn't matter the x, right? If I picked any point on there, for example, this one, right, that's 2, 6. Over here I'd have -3, 6, and so on. So all of those y values have the same value of 6, okay? So it doesn't have an x-intercept in this case. It's missing the x. Now if I looked at the next one, x equals -2, this one's missing the y, so it's not going to have a y-intercept. All right, we've just got -2 here on the x-axis, and it's going to be a vertical line. Okay, again, anything on this line is going to have an x value of -2. Okay, -2, 0, -2, 1, -2, 2, -2, 3, and so on. All right, so again, that was x equals -2. That would graph as a vertical line. Doesn't have a y-intercept. We're missing the y. Okay, so everything else with the exception of those 2 is going to touch the x-axis and the y-axis. Okay, so let's look at how we graph using the x and the y-intercept. Let's take a look at this one here first. Okay, so my equation was 15 equals 5x plus 3y. Okay, now a couple things when you're doing the x and y intercepts. Typically it works best when the equation's in standard form. Standard form simply means that you have both the x and the y on the same side of the equation. Okay, you can rewrite it that way if you need to, but it works best when it's in that form. And then the other thing that usually makes it pretty easy mental math is if your coefficients, your numbers in front of your variables, are factors of that other number on the other side of the equal sign. Okay, so in this case 5 and 3 both go into 15. So that tells me that it's going to be an easy thing to graph using the x and y intercepts. All right. Now, if we think back to what an x-intercept means, it means it touches the x-axis, right? And any point on the x-axis, doesn't matter where I pick, always has the same y value. That y value is 0. So to find my x-intercept, there we go. Okay, I essentially want to make my y value 0 and figure out what my x is. Okay, so it's nice, especially when because 5 and 3 are factors of 15, it makes it quick mental math, right? So if my y value is 0, 3 times 0 is 0. So basically, I'm just trying to figure out 15 equals 5x, right? Well, I know mental math-wise, 5 times 3 gives me 15. So in this case, my x-intercept is 3, right? So I'm basically going 5 times 3 is 15. My x-intercept is at 3. 1, 2, 3. There's my x-intercept. Okay, I can do the same thing for the y-intercept. Okay, anything on the y-axis, right, my x value is going to be 0. So I make my x value 0. And again, 5 times 0 is 0, so I'm basically solving 15 equals 3y, which again is mental math. 3 times 5 is 15. So my y-intercept is at 5, 0, 5. 1, 2, 3, 4, 5. Okay? So intercepts are nice when they're set up, when the equation's set up to use them, because a lot of times it's just mental math. What do I multiply 5 by to get 15? Well, that's 3. So my intercept is on 3 on the x-axis. What do I multiply 3 by to get 15? Well, that's 5. So my y-intercept is at the 5 on the y-axis. Okay? Now, occasionally I'll see students mess this up and go, well, x is 3, y is 5. The intercept is at 3, 5. Right? Again, the intercepts are here. Okay? Your other value is 0. We don't combine them into one point, right? So once I have my two intercepts, I can just draw a graph. Draw my line there. Okay? All right, let's look at one more. Let's go back to this one. 6x minus 4y equals 24. Again, it's set up in standard form. I've got my x and my y on the same side. If I look at my factors, 6, and we got to be careful here. Remember, this is a negative, so if you need to, change that to plus negative. But 6 and negative 4 both go evenly into 24. They're factors of 24. Okay? So again, if I want to find my x-intercept, I basically ask myself, what do I multiply the 6 by to get 24? Well, 6 times 4 is 24, so my x-intercept is at 4 on the x-axis. 1, 2, 3, 4. Okay? For my y-intercept, I basically ask myself, what do I multiply the negative 4 by to get 24? Well, negative 4 times negative 6 is positive 24. Okay, and that's where you got to be careful with the minus signs, right? If you're good at seeing the minuses and negative, you don't need to change it. But I would highly recommend if you make or have issues there, make a lot of mistakes, change it to plus and negative before you even get going. That'll help with that. So because we have to make that a negative 6, not a positive 6. So then I can plot that on my y-axis at negative 6, 2, 3, 4, 5, 6. Okay, draw my line. Remember, we want to put arrows on the end because anything on that line is a solution, and it keeps going forever in both directions. So we want to put those arrows on the end. All right. But again, really easy to graph equations when they're set up nicely for intercepts. All right. Pull this up here. And again, when we're doing intercepts, right, we want specific types of equations work well. It's where they're in standard form. So you've got the x and the y on the same side, 3x plus 2y, 6x minus 5y, something like that. And then the number they equal is a multiple of those two things. So might be like 12, for example, right? 3 is a factor of 12, 2 is a factor of 12. 12 is a multiple of both of those things. Okay, 6 and 5, you might have 60, for example, right? 6 is a factor of 60, negative 5 is a factor of 60. Right? If those two things happen, then it's really easy to use our intercepts, right? We just go, well, 3 times what is 12? 3 times 4 is 12, right? My x-intercept is 4. 2 times 6 is 12. My y-intercept would be at 6. Okay, 6 times 10 is 60, so my x-intercept would be at 10. My y-intercept, again, we got to make that a negative. Negative 5 times negative 12. Okay, so I can plot those points on the plot those intercepts, draw my line through, go from there. Right? It doesn't work as well if it's not in standard form. Y equals 2x minus 4. There's better ways of graphing that. You could certainly make x 0 and solve for y and so on. You could rewrite it in standard form if you wanted to. I could bring the x over and make that 2x plus y equals negative 4. Right? Negative 2 times 2 is negative 4. So my x-intercept would be at negative 2. My y-intercept, 1 times negative 4 is negative 4. So you can certainly do that. There are different ways of graphing when it's not in standard form. We'll talk about slope-intercept later on, but typically your best equations to graph using the x and y intercepts are when it's in that standard form, the x and the y are on the same side, and then those coefficients, those numbers in front of the variables, are factors of that third number. So again, part of the key of being good at graphing and learning to do this stuff is recognizing what's the best strategy for the equation that you use. So again, this is just one strategy that we'll look at, is using those x and y intercepts.